This video is going to talk about double replacement reactions that produce a gas. So in class we'd worked on the double replacement reactions, and that's where they switch partners. Remember, and then we look at the new combinations to see if either of the new combinations would make something that's insoluble, or it would form a precipitate, which we use a solid to tell the state of a precipitate. Well, it's not always that you make a solid or something that's insoluble. Sometimes you make a gas. And there are gases you can make directly, like HCl here or H2S here. But what I want to focus on, and it's one of the homework questions, is when a gas is produced indirectly. So indirectly, you can see here I have H2CO3, H2SO3, and NH4OH, and these are common ones that can make gases indirectly. And what happens is when you switch the partner, you would get H2CO3AQ, or H2SO3AQ, or NH4OHAQ, which would be correct in terms of switching the partners. But then if you were to check it out, you would see really in the back that there wasn't H2CO3. That's because H2CO3 breaks down immediately to make water and carbon dioxide gas. So if you were actually doing this in the lab, you would see some bubbling as the carbon dioxide escaped. The H2SO3 breaks down to water and SO2 gas, sulfur dioxide, and the the NH4 ammonium hydroxide breaks down to water and ammonia. That's where I was headed with that. So what I want to do is look at a problem that results in the formation of H2CO3 and what it would look like. So this is one of the homework problems, and in this problem it tells us that we're going to have sulfuric acid, and it said it reacts with sodium carbonate. Now I would like to take a look. I wrote it in words because I wanted just also to practice nomenclature or naming while we're doing this to keep us thinking about it. Now acids, we know because it's an acid it's going to have H+, and then we have to know what it's what it's with. When it doesn't have hydro in front of it, we know it's based on the polyatomic ion. So if I look here, I remember that ic comes from the polyatomic ion that ends in 8. So sulfuric acid comes from sulfate, which is SO4 2-. So then if I were to write the formula so then that would be, this would be with H+ with SO4 2-. So the formula for sulfuric acid would be H2SO4, and it would be aqueous. Now it's going to react with sodium carbonate. So sodium is an alkali metal, which is the first group, so it has a 1 charge. And carbonate is CO3 2-. It's a polyatomic ion. So looking at the charges, I would say that it's going to take 2 sodiums to balance the 1 carbonate. And we have solutions, which means it's AQ. Now if we were going to then predict what it would form, in a double displacement reaction, they switch partners. So the hydrogen ion is going to go with the carbonate, and the sodium ion is going to go with the sulfate. Now in our textbook, in Appendix 4, there's a solubility table. And if you looked up what hydrogen does with carbonate, you would see it says slightly aqueous. okay? And that slightly, we're going to say, okay, so something's going to happen. And then sodium with sulfate is aqueous. So initially what I would predict this to form is, let's see, so hydrogen and H plus with carbonate, a CO3 2 minus, would be H2CO3. Now remember, this is the one that I am looking out with because this is the one that indirectly forms a gas. And then the sodium with the sulfate would be Na2SO4, and I don't think I can write it, but it would be aqueous. Now the H2CO3 from the previous page, remember, it breaks down to form water and carbon dioxide. So I need to write it that way. This right here is not what's going to be the final product. So rewriting the equation would be H2SO4AQ plus Na2CO3. Now remember that H2CO3 indirectly makes a gas. It breaks down and it makes water and carbon dioxide gas. That's right there. That is my H2CO3, is this right here. And then it will also make, we don't forget, we still have the Na2SO4, and I can't fit the AQ there even as small as I'm trying to write. Now looking at this, I think it is balanced, so I think it would be finished. Part of the reason that makes me think that is because H plus and Na plus are both one charge, and the sulfate and the carbonate are both two. But I'll check. I have one sulfur and one sulfur, two sodiums, one carbon, two hydrogens, and 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it's balanced. And so the equation ends up being aqueous, being this, and that's a 2 right there. It's an Na. See if I can erase it and make it clearer. That's Na2SO4. So the main point here is that double replacement will always have switching of the partners, where the positive ion from the first substance will interact with the negative one, and then the positive ion from the second substance interacts with the negative one of the first one. And sometimes there are substances, a few, that when they combine, instead of staying as that substance, they break down. And in this case, the H2CO3 breaks down into water and carbon dioxide gas. I hope that helps you understand this homework problem, and please let me know if you have any more questions.